Hello and welcome to another one of our walkthroughs of NCEA exam style questions. This time we are doing level 2 physics and we are doing the electricity and magnetism paper. Let's get cracking. Okay, question 1. Some cars have heated seats. The seats are fitted with 4 heating units, 2 in the base and 2 in the back. The units in the base have a resistance of 10 ohms and the units in the back have a resistance of 12 ohms. The heating circuit is connected to a 12-volt power supply. Show that the combined resistance of the base units is 5 ohms. So this might seem weird. We're like two 10-ohm resistors. How can the resistance only be 5 ohms? The answer to that is that they are in parallel with each other. So we're going to use this formula, 1 over RT equals 1 over R1 plus 1 over R2, which is the formula that will be on your resource sheet for resistors in parallel. So 1 over RT equals 1 over 10 plus 1 over 10. So 1 over RT equals 2 out of 10, or 1 over 5. And then you can flip both those fractions upside down or inverse it, to do it to the power of -1. Either or, same result, which is a total resistance of 5 ohms. A nice achieved to get us started. Okay, question B now. Calculate the current flowing through the ammeter. So if we just scroll back up, we can see the ammeter is there, placed in series, as an ammeter should be. So we need to find the total current flowing through it. Now we know the voltage in the circuit is 12 volts, and we know we've got these resistors here. So the current will depend on the voltage and the resistance. Using Ohm's law, V equals IR. So we could rearrange that. So I equals V over R. So we'll need to find the total resistance in the circuit first. So let's start off doing the resistance of the back units. So similar method to what we did in part A. So we'll go 1 over 12 plus 1 over 12. So if we, again, inverse that, and that gives a total resistance of 6 ohms for the back units. Now you'll notice, again, if we just scroll back up, the base units and back units are then in series with each other. So we'll add these resistances, so the 5 ohms and the 6 ohms. And that will give us a total resistance in the circuit of 11 ohms. So now we know that, we can calculate the current flowing through the circuit, therefore through the ammeter. So we do voltage, which is 12 volts, divided by resistance, which is 11, which comes out at 1.09009, which I think we will just round to two significant figures to match the information we were given. So that will be 1.1 amps. And that is the answer. So this is a merit question. You get achieved for working out the total resistance in the circuit. Question C now. The heated seat has different settings. Current. On one setting, one of the units in the base is disconnected. Explain the effect this has on the current through a single back unit. So probably the best thing to do is scroll back up to the circuit and just picture what's going to happen. So if one of the units in the base is disconnected, so if we just get rid of that one, say, then this will now be in series because the current only has one path that it can take through there. So it's actually going to increase the total resistance in the circuit. And what that will mean, we know, again, Ohm's law, V equals IR, so I equals V over R. Increasing resistance, keeping the voltage the same, that's going to decrease the current. So let's put that into words. So when one of the units in the base is disconnected, the total circuit resistance increases. If you want to skip ahead a few seconds and wait for me to write this, then feel free. Okay, there we go. It wouldn't hurt to add to the explanation what I said about the fact that that means that again, if we go back up, let's just see that those base units, well, the one that's still in the circuit is now effectively in series. Not actually required, but I think given that extra detail helps to explain it because that's why it's happening. So we know that V equals IR. So you don't have to use formulas in your explanations, but they are very helpful. So V equals IR. So increased resistance will reduce the circuit current and therefore reduces the current. Okay, so that is a merit question. For achieved, you have stated that total resistance increases and therefore the current through each back unit will decrease. For merit, correct answer with reasoning, and you have to make it clear the current in the back unit is referred to. So you must state specifically not just the total circuit current, but through a back unit. And that is a merit. Okay, on to question D. A high specification car adds an additional heating unit to the seat. This is labelled R in the diagram. When the new heating unit is added, the power output from the supply is 20 watts. Calculate the resistance of the new heating unit. So if we think about the formulas that we want to use, we've got P equals IV, and of course V equals IR. So P equals IV because power has been mentioned. And V equals IR, we know we've got voltage because we know that's still 12 volts. We don't know the current though. So we know, let's write out what we know. So we know the power is 20 watts and we know the voltage is 12 volts. So looking at P equals IV, we can work out I, the current. And then if we work out that, we will then be able to work out R because we already know V, we'll know I, we can work out the total resistance in the circuit. So that seems like a good place to start. So 20 equals I times 12. So 20 divided by 12 will equal the current, which is 1.667 amps. So that's the current in the circuit. So now if we put in what we know here, we can work out that the resistance in the circuit is 7.2 ohms. So that's the total resistance in the circuit, which is not what we've been asked to find. We need to calculate the resistance of the new heating unit. But now we know the total resistance in the circuit, that will help us do that. So the total resistance will be the 5 ohms from here. So this was from the first question. Remember part A, we worked out that that was 5 ohms. So we don't need to work it out again. So plus, we're going to have 1 over R plus 1 over 12 plus 1 over 12. We'll inverse that. Okay, so we've got 2.2 equals 1 over R plus 2 over 12. And so this is all still to the power of negative 1. So inversed. So if we just rewrite that as 1 over all of this, now times both sides by that equals 1, then divide both sides by 2.2. Don't want to forget the 2 over 12. Don't forget that. And then just rearrange this. So 1 over r equals 1 over 2.2, take away 2 over 12. So then r will equal just the inverse of all of that. And that gives us an answer of 3.5 ohms. Now be pleased to know that's an excellence question. So for achieved, you found the current. For merit, total resistance. And then for excellence, the resistance that we were asked for there. And that concludes question 1.